So number 10 is similar to one we did yesterday as well, except instead of dividing our rectangle into 3, we're dividing it into just 2. All right? And they're giving us this fixed area, which is 216 square something meters, and we want to know what's the minimum amount of fence we can use. So we got to, again, write variables for our dimensions. I'm going to call this the length, and this whole side here the width. Okay? So the amount of fence we have to use, which we can call F or perimeter. It's not really the perimeter because we're using that interior piece as well. So the amount of fence we have to use is we have 2 W's for the top and the bottom there, and we have 3 L's, which are right here and right here. Okay with that? Now the perimeter, we don't know what the perimeter or the amount of fence is because it's going to change depending on our dimensions. We want to find the minimum amount we need. That's based on the fact that the area has to be 216. But the area we also know has to be this awesome equation, length times width. So that's what we're going to use to sub out for our fence equation because we want to derive the fence equation because we want to minimize that. So we know that W, it doesn't matter which one we solve for here, W is going to be 216 over L. Okay? And when you plug that into our fence equation, you're going to get 2 times 216 over L, which is 432 over L, plus 3L. Again, I'm just plugging 216 over L into W here.
Wait, what's F?
The amount of fence. Okay? And now that we've got it just in terms of one independent variable, we can derive it because we're gonna make a little number line again. Okay? So remember we have discussed if you're deriving a fraction like 432 over L and the numerator is just a constant, you don't need to do the quotient rule. You just get negative 432 over L squared, and that's really just the power rule. All right? Again, because so what I'm doing there, gang, when we do that, and this is something we've done a couple times, is I'm rewriting that as 432 times L to the negative 1. Okay? And we're doing the power rule. So you get negative 432 L to the negative 2. And then you drive the 3L, and that's just 3. But what are we going to have to get? Anybody? Thank you. Oh, my God, Danielle. Thank you so much. We got to get a common denominator to find out where this is going to be 0. The common denominator, hopefully you see, is going to be L squared. So we got to multiply the 3 by L squared over L squared. Guys, I'm going pretty fast with these here, okay? So tell me to slow down if you need me to. I'm just trying to get several examples down for us. That's going to make this whole fraction here, the derivative, 3L squared minus 432 over L squared. To find out where that's 0, we're going to do 432 divided by 3 is 144. So L squared has to equal 144, which means L must be 12 feet. Feet, meters, meters. Okay, 12 meters. Okay with that? And if L is 12 meters, we're going to come back up here to because we got to find W. Remember we said W had to be this, 216 over L. So 216 divided by 12, is that 18? So W has to be 18 meters. So they ask us, what do they ask us for here? Say what dimensions for the outer rectangle will require the smallest total length? That's this right here. Okay? And even though I didn't do it, we know that's going to be a minimum when L is 12. So you set it up like this. Because if you plug a number in less than 12 to the derivative, you get a negative. If you plug a number greater than 12 in, you get a positive. Okay? And I'm plugging into this equation right here. That was our derivative. Cool? So that's a minimum. And then they ask, what is the minimum area? No, it says how much fence will be needed. I'm sorry. And then for that, we can go back up here to our fence equation, which is 2W plus 3L. So it's going to be 36 plus 36. So the amount of fence needed, the minimum amount, is going to be 72 meters. Okay?